So in this question, I've got two triangles. I've got this right angled triangle here with angle E, adjacent side 4x minus 1 and opposite side x. Here I've got a right angled triangle with angle F with adjacent side 12x plus 31 and opposite side 6x plus 5. We need to find x, and we're told that the tangent of E is equal to the tangent of F. So how are we going to go about solving that? We're given an angle and what it's equal to, we need to find x. So first of all, let's use the definition for tangent in SOHCAHTOA. So tangent of any angle theta equals opposite over adjacent. So if we do that, that will give us our tangent of theta. Now here we're given that tangent E equals tangent F. So if I write that here, tangent of E equals tangent of F. That's our starting point. Now with this identity here, opposite over adjacent is the tangent of any angle. So here, tangent of E. So tangent of this would be opposite over adjacent. So therefore I've got x over 4x minus 1. That's my tangent of E. So if I just put that there, then my tangent of F, in this one here, opposite over adjacent, so that would equal 6x plus 5 over 12x plus 31. And that's tangent of F. Okay, now setting these equal to each other should be able to solve for x. So let's have a go at that. Now, first things first, let's get rid of the denominators. So let's get rid of this one first and then multiply both sides by 4x minus 1. So if I do that, multiplying this side by 4x minus 1, I'll just be left with x. And then on this side, I'll have 6x plus 5 times 4x minus 1. That will take care of that. And then divide by, still left with this one here. So now, as I did with this one, if I multiply both sides by this, I can now get rid of this denominator. So now let's times by 12x plus 31. So I just put those in a little bracket as well, just to not break any BODMAS laws. So times this by this. So then I've got x times 12x plus 31 equals, then I'm just going to cancel out my denominator and be left with my numerator. So then I've got 6x plus 5, 4x minus 1. Okay, now I can't really divide anything there. There's nothing else that will factor out from there to cancel anything out. So I'm going to have to expand all of these brackets out. This one is this slightly easier case. Distribute x into this. So I've got x times 12x, 12x squared. And then x times plus 31 is plus 31x. This one a bit more tricky, but not a problem. Let's deal with 6x first. So 6x with 4x, so multiply those together. 6 4s are 24, x times x, x squared. So it's 24x squared. And now the 6x with the minus 1, it's just minus 6x. Okay, now the 5. 5 times 4x plus 20x. And 5 times minus 1, that will now give me minus 5. Okay, right. Now I've got the bigger x squared term over here. And I've got a smaller x squared term over here. So what I'm going to do is bring everything over this side. And I should be left with a quadratic equation set to 0, which hopefully I can solve. So I'm going to bring all this stuff across, so they'll be left with 0. So 12x squared over here, subtract 12x squared from both sides. So 24 minus 12 is 12. So that'll be that. Let's take care of business here first before we bring the 31x across. I've got 20x minus 6x, that's plus 14x. and then plus 31, bring that over the other side, I'll have minus 31. So 14x minus 31x is minus 17x. And then here, I've just left with minus 5. Okay, so now I need to try and solve this quadratic. Now that looks pretty intimidating, so let's see if we can factorise it first using a special technique. So 12x squared minus 17x minus 5. So instead of drawing up grids and crosses and everything, what I do is I take this 12 and multiply this integer by this 12. So I've got x squared minus 17x minus 60. And then let's see if I can factor this. So much rather factor this than this. So I've got an x and I've got an x. Now I'm going to have a plus and a minus because I've got a minus here. So factors of 60 with a difference of 17. Well, straight away 3 and 20 catch my eye. 20 minus 3 is 17, or 3 minus 20 is minus 17. So I'm going to go plus 3 minus 20. So that's that factored. But I don't want the result of that, I want the result of that. So what I've got to do now is bring this 12 back to here. So what I'm going to do now is divide all of these numbers by 12. So divide that by 12, divide that by 12. So then I'm going to be left with x plus a quarter and x minus 20 over 12. Well, divide that by 4 and divide that by 4, I've got 5 over 3. Okay, now that is factored, but I would prefer to bring it back into this term here with the 12x squared. So now what I'm going to do is I've got a 4 and a 3, so multiply up by 4 inside here. So then I'm left with 4x plus 1. And then multiply by 3 in here, I've got 3x minus 5. And that would be that factored. Okay, now my solutions for that, I've got this over here. So 0 equals 4x plus 1 and 3x minus 5. So now what I'm looking for, solutions to any of these, one of these will be 0. So then I'm left with 4x plus 1 equals 0. So 4x equals minus 1, x equals minus 1/4. So I would have got that from there. And then likewise, the same with this one, 3x minus 5 equals 0. 3x equals 5, x equals 5 over 3. Now, what I've got here, if I plug x into any of these, I need to get positive terms. I can't have a negative distance. Well, I've got an x on its own here, so x equals minus 1/4, that's out. I can't use that. So x equals 5 over 3 is going to be my solution. So x equals 5 over 3. So let's put that over there. That's the answer to my x. So let's plug it into the values here. So then I've got 5 over 3. X is 5 over 3 here. I've got 20 over 3 minus 1. 20 over 3 minus 1 is 17 over 3. And then 6x times 5 over 3, that's 30 over 3, which is going to be 10, plus 5 is going to give me 15. And then I've got 12x plus 31. 12 times 5 is 60. 60 divided by 3 is 20. 20 plus 31, that's 51. So I've got 15 and 51, and 5/3 and 17/3. So if I multiply this by 9, I will get to 15. Multiply this by 9, I will get to 51. So I can see that these are congruent triangles. So I'm happy that my answer for x equals 5 over 3 as my solution. Okay.